Good evening, everyone. The call has officially is being recorded so that we don't have to tell stories for today, right? So, welcome back for today's class. I'm excited to be here with you guys for today. So, the last class, we were just without knowing that some of us are not really following, and I didn't want to just continue going in the name of let's cover the curriculum, and at the end nobody understands what you are doing, right? So that's why I needed to pause for some time, so that we could flow. So I don't know how many of us went through the recorded sessions. Please, if you did, kindly indicate. If you have specific questions, you can ask so that you can start from there. Did we go through the recorded session? Um, Sarah said she did not. Um, I'm not response. Only Sarah is responding. The other persons, if you have specific questions, you can ask, right? Okay, so many people have not gone through the recorded session. It's actually not encouraging though. Irrespective of our reasons. I mean, I can understand the people that are sick, but then everybody has a tight schedule, right? And you are meant to put this boot camp to factor it in your schedule. Okay, so where do I start? So I'm just going to do like a quick overview before we continue. When we started this class, we introduced SQL. We said that SQL is structured query language. It helps us to interact with different database or tables at the same time, unlike Excel. Although Excel has been able to bridge that gap using Power Pivot, but that's advanced Excel. So company like what likes to work with SQL because of its ability to handle large, like millions of data sets without crashing or getting slow, right? And for you to query this database, there are syntax, there are clauses that you use. They are divided into three. You have the data definition language, the data manipulation language, and data transaction language or query language. So when you talk about defining, that it means setting the structure of your database. You want your database to be structured. By structuring, you mean what tables do you want to be inside that database? And that's when you start using the keywords of create, keywords like drop, because if you are creating something, you're defining the structure. right? And then when you talk about the manipulation, it's the table you've already created. You want to be able to access it. You want to be able to retrieve data from it. That's when you start using select, alter, update. What you've created before, you just want to manipulate it without changing the structure. And then you have the query language, which we started getting into in-depthly from the last class. So SQL can be a lot, but what helps me to learn SQL is that I see it as a normal English language, right? Starting from this great database, we discussed what a database is. A database is like your workbook that can contain a lot of tables. So it's like a folder where you store files, right? When you open your system, I know you have so many folders. So these folders, you store different files. Inside the database, you store so many tables. We are talking about UNN and school database. We can talk about the school database having the tables for different departments. Inside that department, you still have tables for different levels, right? So a database is like the container, the grand folder. Then when you create a database, this is syntax, create database, the database name. It's also important to indicate, use this one here. This one is saying that I have so many databases on my schema. This is a database, 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 like so many of them. If you don't indicate the one you're using and you start creating tables, first of all, it might not run because there is no specification. Even if it ends up running, the table might be created inside another database that you don't want, that is not your intention. So when you specify use a particular name of a database, it automatically selects it, right? And then after your database, you create tables that you want to work with. In the first class, we talked about creating tables, either creating it manually, importing already made table, importing already existing table, just like the data set that we use for our Excel classes. So um, to create the tables, we use this syntax. First of all, this drop table is that if this table was existing before, we want to drop it and recreate. So it's just like a simple English drop table. This is the table name, right? And then to create a new one, you create table and just give me a minute. Okay, sorry, I had to attend to someone. Um, so I was trying to say the creating table part. So it's just like normal English, create table, the table's name, and this semicolon is for terminating to say that that particular line of code or query is finished, that the next one is a new set. So if you don't do this, it's going to drop an error, right? So we create the table and If we are creating table manually now, just like we did, we need to create the attributes of this table. Attributes are like the columns. So you should have a first name, age, department, score. And then we talked about the data types that can be attached to each of these data types, column names. If it's string, it's varchar. And once you're dealing with varchar, you need to indicate the length that should be, that's that first name. Like this 20 means that the first names must not exist 20. If you are typing a name that exists 20, it will not run because you set a constraint that the first name, like the length of the names, must not exist 20. So that's the 20 in brackets. But when you're talking about number, there's no need to indicate the length. It's just integer or float. There are numbers that can be floats. When you're talking about price, you can use floats because the price might come with naira and kobo. If you're talking about somebody's age, it's strictly whole number, right? Or years. So these are the things you think about when you're creating your tables and attaching data types to them. Then moving on, after creating the table, you would like to see everything that is created, like that your table looks like. So you use the syntax select. Select means out of select. The normal English word, select this thing for me. I want to select this. I want to select clothes. I want to select cars. Just select everything. So in SQL, everything is star, right? So it always goes with from because you have to pull it out from somewhere. So you select everything from students. And when you run this thing, it selects everything from your table. This is table. Because we've already inserted values, that's how these values are here. This is what we did in the last class anyway. So this is your insertion into the tables. So you will do it in the order you want it to appear, right? If you take a look at what we are having here, you actually pay it's in the same thing. But if you created first name, age, department, score, but then you want your table to come out in a structure where age is first, that means the age will come here followed by first name. Like what I'm trying to say is that Mary, this is the age, this is the department, and this is the score. If you would want the department to start first, to be in the first, to be mentioned first before the first name, that means you have to exchange this and put it here. That's that way. Whatever that will be on this column will automatically be the department, right? So we inserted these values, right? So the only way you can learn this is practice. If you don't practice it, you won't learn it. Like there's no amount of teaching I can give you unless you practice it. How do you insert values? You will make mistake. You correct yourself. You will say, okay, this is the mistake I made. Next time you will not make it. So after inserting your values, you run your program, and then you still select everything to view the values you inserted. Now, select has a lot of things you can select. You can decide to select everything by using star. It will show you your whole table structure. But if you want to select a specific columns, you can select one column, you can select two, you can select 10, as many as you want. But the rule is that if you write the first column, you put a comma. If I wanted to select another column, I'll just put another comma and put age, right? If I want to select another one, right? So you always make sure that the names you are selecting is the same thing with what you use to define it. Because when it comes to your column names, it's case sensitive, unlike reserved keywords in SQL. If I run this thing now, okay, it's actually run. So in reserved keywords, what I mean is that if I decide to write this select statement in small letters, it will run. The same thing with if it's a capital letter, to still run. So, but where this thing will have an issue is if this is this. So let's run. Still running. So I think once the structures are the same, you are good to go. And then, so those are how to select different columns. Out of your whole data, you just want to see some specific columns. You don't want to see everything. You mentioned the column names you want to select. Of course, you're selecting it from somewhere. That's distinct. Now we talked about distinct, right? Distinct is like give me the values that are in my table without repetition. Now, if we check our data sets, you're having people who come from maths, computer science, and it's being repeated, right? The same thing if there are repeated ages, but you just want to see, okay, I just want to know that there is maths, there is physics. I'm not interested in knowing how many times that appears. You use distinct. Use distinct. I don't know if that makes sense. And then you talk about filtering. I try to make this thing a logical flow whereby you talk about filtering, you talk about sorting and aggregation, sorting and ordering, talk about aggregation. So these are the things you do to explore your data. So when you hear about exploratory data analysis, this is how it's done. You filter some of your data sets, you sort it. You are exploring the data set, you are trying to understand your data set. So one of it is filtering. So when you want to filter, there are so many things you can filter with, right? So to filter, you use where clause. So this is the where clause. Where clause is like giving it a condition where this is this. So first of all, we want to select the first name. We also want to select the ages of the people in that table. And we are pulling it from the students table, right? So now, if we just run this, it will give me all the students and their first name and their age. There is no condition to it. But I just want to filter for students who are above 20 years. I don't want teens. I don't want to see teens in my class. That's 19 years and above. I want 20s and above. So you put a condition that's filtering a subset of your data. You're pulling out a subset of the data. You're not interested in everything. You're interested in on some people who meet a certain criteria. So you have to use a where clause. Where this is true, it should do this for you. So because we're interested in people who are above 20 years, we include this where clause. And in this case, we are saying where age is greater than 20. So when you run it now, it will just pull out these 4% because they are the only people whose age are greater than 20. Now, there are so many things you can in terms of logical comparisons or arithmetic logics. You can use greater than, there is less than, there is greater than or equal to, there is less than or equal to, right? I think, yeah, these are the ones you can use in terms of arithmetic operations. Then in terms of logical operations, you talk about and, which we are coming to right now. So now this is where to use there's also equal to under the arithmetic operations, like where you can use combine it with where. So this one is where department is computer science. We're interested in students who are only coming from computer science. Every other person should be excluded. So it pulls out these two persons because they are the only people who meet this criteria. Then you talk about logic functions. So you know when to use what depending on the question you are asked, right? I'm thinking that by next week we will actually do, yeah, an SQL project where we start from start to finish to do the project. But before that, I would want us to be able to touch on joins because we will need to do some joins and subquery. If we cover joins and subquery, I think we are all but so joins and subquery is an intermediate stage, which is okay for you at this level. That should help us to actually do a very good project in SQL so that you then know how to apply all of these things that we are learning in one setting, right? So for now, just understand the basics. Because I always emphasize on understanding the basics and the concepts because that's what you build on as you go. So now, when you're also doing where clause, you can also decide to use logic functions. Logic functions are your and, your or, your not, right? So this is and. If it's or, you use the or. If it's not, this is for not. Exclamation mark and equal to is not. You don't spell it like not. You use this to indicate it. So what we said here is that we want to select everything from students, and we just want where departments are mathematics and their score is above 75. Let me make it 70 so that you know that 70 is A. We're interested in mathematics students who got A's. So if this question was like, how list students from maths departments that got A's, this is the query that you should write to pull that data out of your database. And when you run it, you have just two people, right? If your interest was those above 75, and still indicate it, and to pull out just one person. So this is the only person in the maths department that scored above 77, right? And then we talked about notes. This notes now is we are interested in everybody except students that are in physics department, right? So this is the notes. And when you run it, so if you check the department, you should not see anything in physics. You should not see anything in physics. Then there's also between. There's also between. When you see to start from 20 and above. So now when you say between, you're talking about a range. You're being specific. You're not just talking about people who are above 20. You have a set of people in mind. People who are between 20 and 22 years old. So it will include the 20 and the 22. So when you go ahead and on, you can see that their age here, the age bracket there is actually people still matching of. Hello, can anyone hear me now? So I think my network stopped. Okay. Yeah, my network stopped at some point. All right. We've been following Have you been following? So that I will not hear SQL is hard again. Because after this explanation, we are going to get hands-on to try to answer some questions. So I was in the, I don't know where I stopped. I think I lost connection when I started talking about the pattern matching. When you use like, maybe you are interested in people whose name, I think I remember correctly that I said maybe I'm interested in people whose first name, like their surname starts from A, because I want them to be in a different, maybe in an exam. And my screen is not showing how. Okay, I think we're back. Still the network, still network issue. So I said the last part of filtering that you want to do, where you can use your where with the conditions you can use with where is the like. So like is using this, what's it called, percentage sign or modulus. If you are talking in terms of, right? How many people offer maths? Mm, how many people offer maths? Ah, that's a long way back. Are you serious? Whoa. Okay. So this is for maths. I think I'm done with that. Well, so this is for where people who offer maths and their age is above 75 years. And then we talked about not. You don't spell not N-O-T, unlike your and your or you, when you want to spell or, you can, when you want to use or, you can actually spell it the same thing with and. When it comes to not, this is the sign for using not, exclamation mark and equal to. So you're interested in people who, every student except those that are in physics class. So another way, can anybody tell me another way we would have done this if we don't want to use where clause, right? The question this thing is answering is that I want to show students who are in, except those that are in physics. Is there another way? I'm trying to think. Is there another way? Okay, no. We actually have to use the word close. We can actually, okay, that would be in advanced filtering, where we can say where department in. So when you use in, you put bracket and start listing those departments, mathematics, and the rest of them. So I think that that should be in advanced filtering, which is the next thing we'll do. So let's leave it as simple as it is here. So now we talked about the inclusiveness when you are talking, have a specific range of persons in mind, right? Before we said people who are greater than 20 years old, greater than or equal to 20 years old, but then we then went ahead to talk about actual range of the age bracket that we are looking at. That's people who are between 20 and 22. So when you run this, it will actually pull out data for these two people, right? We are having 23 here. Let me run it again. Yeah. So I actually ran this one. Actually, I don't know what gave that result, but this is what we are having now, 20 and 22. So if you look at the age, it should be between 20 and 22. Then what I was talking about pattern matching. Pattern matching is that once a specific sign or symbol is in the indicated column that you're talking about. Okay, somebody's not muted. I can hear myself. No, no, no. Yeah, I think Nena is not muted. I can hear. Nena, please mute your mic. Okay, so I'll just it's very bad. Um, okay, so we're talking about pattern matching, and I can hear myself. I seriously can hear myself. It's actually echoing. Like when I talk, I hear myself clearly. I talk consistently. Like there's no difference between what I'm trying to say next and what I just said. Um, and then is not muted.
But this guy will spoil the man.
Well, I think you can mute her from your end also.
Okay, I think that works. Yeah, thanks for that suggestion. Thank you. Um, so for the pattern match, right? I'm just losing my train of thought. So we're talking about pattern matching. Remember, we're still talking about filtering. All of these things are like conditions for filtering. So in this case, you're interested in people. Let's say that in these names, first of all, let me select everything without condition. So these are the students that we have. And I'm interested in students whose name starts with A, right? So how do you know for student that starts with A? The letter you're interested in, or letters in this case, if I'm interested in AG, if I'm interested in ADY, as the letters can be, doesn't mind, it will still run it for you. As far as those students' names start with this, it will run. So I'm just interested in students whose name starts with A. I'll go ahead and run it. And to pull out only students whose name starts with A. So instead, you have Sterling may have an error. Okay, yeah, that's because we did remove this. So I'll run this again. So these are the students whose name starts with A. And what if I'm interested in students whose name starts with A? So the letter will now be at the back of your modulo sign. And this is what we are, right? These are students whose name starts with A. Remember, it can be as so many letters as you want, and like as so many as it is, right? What if I just want people who any so far A appears in your name, just pull it out. So it will be the letter will be in between two modulo sign. So this is just for you to know the difference between when you're looking for something that starts, something that stops, and once it is contained in that word. So that is for this. Then after that, we started with sorting and limiting, right? So for you to sort, just like in Excel, when we wanted, if when we drew when we visualize our charts, we wanted the highest to indicate first, followed by the lowest. So we wanted the highest to be sorted first, followed by lowest. So I hope you know that there's a difference between sorting and filtering. Filtering is I want to see a subset of my data. Sorting is just arrange it for me in from highest to biggest, or from A to Z, or from Z to A, ascending and descending order. That's just sorting for you, right? So then you talk about limiting. Limiting, it's you are pulling everything, but you are returning a certain number of rows. It's different from when you're talking about where, right? Where you're dealing with the column itself. When you're talking about limiting, you're limiting the number of rows that should be displayed in your output. So the examples that we use, the first example, we talked about people who score the highest in your department. We want to see them first. So highest scores first. If we don't put this order by, let me comment it out. If we don't put it and we run this query, let's see what we have. So now we've run this query. These are the students and these are their scores. It is not arranged in any way. So it's the output is showing the way we entered it. When we inserted values, we started with Mary Smith over here. So the way you enter this is the way it's going to appear. Mary Smith, this, Nena, this. We were not keen on their alphabets or the scores. But this question wants to see students who scored first, right? Who scored highest first. So that's why you use the order by in this instance. What is it again? I'm trying to not take much of our time doing this because I want us to do hands-on exercise so that by next week we'll just touch on join and query. Then we'll do a project from start to finish using SQL, and then we'll move on from there. So I want to be sure that this part of the class is taken care of, that there's no confusion. Even if that's what we achieved today, is a big win for everybody, right? So now, the way we selected this thing, it's appearing the way we entered it. Even if you import your data, once you select, it's appearing the way that data was structured, like Excel. Now, what if you're interested in some order? I want to order by score because that's what this question is about. We should order it by score. So now you order by score and you put descending order. So when you run, we are now starting from 79 down to the lowest. Remember, we said in the last class that if you do this thing and you do not put descending or ascending, by default, you are saying ascending, right? So once you don't indicate whether it is descending, by default, SQL takes it that you want ascending order, that's from smallest to biggest. But if you what you mean is the opposite, that's descending, you really have to now indicate it, right? By using DESC. So this is descending. If we wanted to sort or order by first name, what we'll just do is to change what we are ordering by here to first name. And if we run it, instead of doing it by their score now, you're starting with people in alphabetical order. U, then N, then A. If you wanted to start from A, like, would still not put descending and to start from A. So depending on the question you're trying to answer, right? And let me change this back to score. Descending. Good. So now this one is saying highest students. Highest students is still like, okay, this is the list of student scores, right? This is the list of the students and their scores. But I'm interested in just one student who is the highest. I'm not interested in a lot of persons again. I just want to see who is that single person that has scored the highest in my class. That means I'm expecting only one person in the output. So that is where the limit comes in. This thing is the same thing that we wrote in the first place. Select the first name and score from students where score is above 75. Okay. I think I'm commenting this out. It doesn't fit in here. So first name score from students, you order by, right? You can agree with me that this is exactly what we did to get this output. The difference now for this particular question is that we limit it to 1. So this is where your limit function comes in. Remember, limit helps you to just filter the number of rows you want to display. This one is displaying all the rows. but we just want the highest person, so we limit it to 1. And it tells us Adakole is the highest person. If we did not put this descending, it will bring out the lowest scorer, which is Nenaobi, because first of all, it will first of all run this order by. And remember, once you don't indicate descending or ascending by default, you are telling it that you want to run ascending. So it will run it in ascending order, meaning that Nena will be displayed first. This is what I mean. Order by score. Okay, I need to terminate it. So now we do not indicate ascending or descending. So by default, it is in descending order according to score. Now, if you do limit 1, the limit 1 is it not this one, right? Limit it to the first row. That's what you're saying. So it will limit it to the first row, and it will now bring out Nenaobi as your answer. So in this case now, this is the lowest scorer. Nenaobi with a score of 79. You can limit as many as you want. Once the least 5 students in your class, you limit by 5. You want the least 2 persons in your class, you limit by 2, right? So this is how you order and you limit. Then we talked about aggregate function. Aggregates, like we know, when you hear aggregates in your mind, you know there's a calculation to be done. So now what kind of calculations are we talking about? Talk about count, talk about sum, talk about average, we talk about your minimum and your maximum, right? You can also talk about the length. Maybe you want to count the letters of your name. You can now use length. So by default, all these aggregate functions are already inbuilt in my SQL. You just need to identify their right keywords. It's just like when we were in Excel, we could do these aggregations. There's average in Excel. It's just that in Excel, you spell the average in full, but in SQL, you spell it as AVG, but it's still the same thing, right? There's count, there is minimum. So these are the examples that we used. So now, I'm going to take this example one by one.
I have a
So,
question.
okay.
Okay, so before you move on, the part where you did the limit, before you did the limit for 2, you did the one for 1, and it returned in an OB 67,
Yes.
the score at 67, and then when you increased it to 2, it returned in 67. So what method did you use? Because they both have the same score. So why did it return the? For what method is it using to return the value?
Okay. So, if I get your question correctly, you know that these two people are different names, irrespective of their scores, right? So there is also something that is called window functions, which helps it to rank. Although we are not seeing the ranking here, but it's actually ranked it. Now, there's window functions like row number. There is window functions like your rank. There's window functions like your dense rank, which we should actually touch on because it's also important. So now what this thing does for you is that it ranks the scores. Because we are interested in the scores, it actually ranks it. Now, it gave this one a rank of 1, it gave this person a rank of 2. And what is happening here is row number rank window function. If you want, what is happening here is row number ranking. So it gave this person a rank of 1, gave this person a rank of 2, irrespective of the same score. Now, when we get to window functions, when we treat it properly, we don't want a case where 2 people having the same scores are having the same ranking, right? We can then use another window function like dense. So I just want to explain that why this thing is pulling out these 2 persons is that they are different people. Number one, the spellings of this name and the spelling of this name are different, irrespective of the fact that they have the same score. So it will just actually say that, okay, this person has 67, this person has 67, so it's pulling out the both of them. I don't know if that makes sense.
Yes, it does. Thank you.
All right, so any other question? Any other question? Okay. So I'm trying to see if I can actually show you the ranking. So we have select first name, select the score, select also the row number, right? And over partitioning by the score or first name, because we want it to pick persons by their first name, order by, we're now ordering it by the score, right? And we call it row number. So this is partitioned by, and let's run. So you can see what I mean. Let me remove, first of all, let me remove this limit by, I'll remove it so that it will list the whole scores and students according to the ranking it gave it. So underneath, there's a ranking that is happening. So it gave these people order by score, descending. Okay, so it's actually giving them a rank. So it's giving them the same ranking, which is not supposed to. This is the rank. Network is bad, but you can see my screen, right? Can you see my? It's going on and off. I think it's the same for everybody. So I would partition by score and see what happens. And then I'll remove my order by. Okay, yeah, so this is Nena Obi. I would also want to select their department because I think it ordered it by department. Okay, yeah, so now this is what we are having. And this is Nena Obi. Both of them are from physics. So because the name alphabetically, Nena actually should it come before Nena Obi based on what we entered, right? So it gave this person a rank of 1, gave this person a rank of 2, then um this 74. So we're actually interested in the score. This is 67, this is 67, this is 74, this is 74. So it looks at their scores. Both of them are having the same score. Say this is rank 1, this is rank 2. These people are having the same scores. This is rank 1, this is rank 2. If we don't want these tied ranks, then we'll start using something like dense rank. So I think you're going to understand this ranking better when we do the window functions, because there's dense rank, there is dense itself, there is rank, then there's row number. These are the window functions that you use, and a lot of others like lag to actually give rankings to your query. So when we now do limit 2, which is what we had, then to now pull out these two for you, right? Based on it is in small letters. My screen is actually zoomed. So if we wanted those who um who scored highest, this would be it, right? So now I'll comment this out. I think I'll just change the layout. Okay, I think we should work with this so we have more. I think it's from your network actually, because I don't think every other person is having the same issue. Or are you guys having the same issue as him? So another question. Yeah, I think it's from you. Before we go into the aggregate function, any questions? No, no question. Okay. So when I was talking about aggregates, I mentioned that when you talk about aggregates, you're actually doing some calculations, counts, minimum, maximum, average, mean, and then some custom calculations, because you know that when we are calculating the, what is it called, what did we calculate? If we had quantity and we had price, if you want to know the total price of that good, it will be quantity times price. That's what I mean by custom calculations. So if there are columns that you will need to calculate, you can do it by yourself using all the arithmetic signs, arithmetic operations, right? So all of them are under the aggregate function. Once you're performing calculations, although aggregate sometimes means strictly summation and its parts. But then I'm trying to like talk about the arithmetic operations you can do in SQL and how you can go about it. So now when you talk about count, count how many people are in my class. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sum, there's a difference between count that's and sum, so that you know when to use it. Sum is add up things. If I'm summing the number of people in my class, I'm going to do 1 plus 2 plus 3 plus 4 plus 5. That's like cumulative addition, right? So now, what I did here, I'm going to cut this off. And then I'm going to, I'll run this just to count the number of departments that are the number of people. So we have 8 students, that's why you're having 8. Ideally, these 8 people are coming from just 4 departments. So how will you know? It's by using distinct. That's when you now use these distinct. So when you run this now, it will just show you that there are 4 distinct departments, right? So all these things are depending on the question you're trying to answer. The first question will be like, just give me the number. If you can do it based on the number of students in my class, you count everything, right? Then if you are interested in just the number of departments distinctively, like no repetition, we already talked about distinct up in the beginning parts, like unique what is it called, unique values in your data. So you do count distinct departments, right, from students. So now I think this is where I introduce the aspect of aliasing. Alias is like, if I remove this thing now and I run this, the name is long. It's telling me count distinct department, right? But you don't want this thing to always be here because it doesn't really look nice. Where you know it's not looking nice is you select first name. And I run this. It's actually not going to run because now it's going to tell us to do a group by. So I think, but the point is that aliasing helps you in 2 ways. Number one is when you do your aggregate function and you run it, what it's going to appear on the header here. It's whatever thing you typed here. So even if it's as long as whatever it is, it will appear that way here. And most times it's very confusing, because if you are doing nested queries, it's going to be very confusing and long. So in that case, you use alias. Alias is this AS, then the name you want it to actually appear as, right? So if you don't want to use AS, you can just put a space and still run your program, and to run it, right? But most times you just use it, at least now they're starting out, so it doesn't confuse you. The same thing here, I can decide to alias um this table as S. If my table name is too long that I don't want to be typing it out, this one is especially when you're doing joins, like you're working with 2 different tables or 3 different tables, and their table names are long. You can use alias, just S for students, D for a departmental table. So now when you're now calling that table, instead of writing S in students in full, you just write S. Once you write that S, it's already telling you that you're referring to students. So that's what aliasing does for you. It's not a big deal, but it just helps for readability and all of that. So that's for count. And then talk about average. Remember, it's AVG, not average in full spelling. So average, you already know what average is. Average is the mean. So I'm interested in average of students' age in my class, so that I can say that, okay, in my class, approximately on the average, I have students who are aged 20 in the class, right? So you remember, if you don't put this your alias, it will run it and to give you this. Most times it's descriptive, most times when it's too long it becomes very bad, so you put it back. And then we talked about maximum and minimum scores. So max and min, very easy, right? So maximum score is 70 and the minimum score is 67. Then talked about total. Total is not when you're talking about score, sum rather. So you use the total function. So what we did here, we combined aggregate and filtering, right? If I decide to comment this out, what I'm interested in, if I run this particular one, these 2 lines of query, I'm actually saying, give me the sum of the whole scores of students in my class. But then when I use this filter, remember your where, you're saying I'm interested in the students' scores, quite all right. But the students I want to check out in this case are students who are in mathematics department, right? So now you're saying that, okay, out of 560 something scores, 159 came from students who are in mathematics, 151 came from students who are in mathematics department. So I think these are the other corrections examples that we did. Then the last thing I think we did, it's this group by, right? So group by is like you are grouping by a specific subset. What, like for example, if I use this example to explain. So now this is the different departments we have. So it picks out the distinct departments and it's telling you that in each department there are 2 people there. So that's what group by does for you. So you select the department, count of students per department. If I wanted it to group by the what else should I use, by their age, assuming that there is repetition of age. So I want it to group by age. So we count everything as, I will run this to list out the different age that are here and how many times they appeared. So 22 appeared, age 22, there are 2 people that are age 22. 19 persons, there's only 1 person. 20 persons, there are 2 people that are age 20. So you see what's happening here. You can actually still order by this age. in ascending order. So like I said before, how do you know if your order by should come before your group by? There's this thing. If you write a query and it pops up that red mark, you know your one is that your syntax is wrong. Is that Number two is that the way you placed it is wrong. For example, if I carry this from students and I place it here, it will definitely throw up an error for me. It's not that my syntax is wrong, it's the placement that is wrong this time around. So put that in your mind when you are debugging your query. Once what you are writing is wrong, this mark will actually appear. Like this red thing will appear. Once you are seeing it in your mind, you should know that your query is wrong. At least now that you're starting out, right? So now, what you should ask yourself, there are two things. It's either your syntax is wrong. In this case, there's not supposed to be a comma. Or the placement is wrong. So now when I run this, it's actually, this is 24, 23, 22, 20. So first of all, it actually did the grouping for us, but it still ordered it for us, right? You can see that because we use order by age in descending order, it started listing the highest age first, down to the lowest age, which is what we are having here. So another thing is learning how to combine these different things. But when we do our projects, we learn how to put all of them together. So I think those are the things that we've covered. Then the last thing is the difference between having and where, right? So having is also a filtering clause, just like where. But then you use having when you do an aggregate function. If you use where when you do an aggregate function, it's going to throw up an error for you, or it will return a wrong answer, right? So now I'm having where. First of all, this thing is telling me that this is wrong, right? I'm not supposed to have where because I have done an aggregate function here, average score. So whenever you do your aggregate function and you still want to filter, please, the right filtering clause should be your having. This is always a popular interview question. What's the difference between having and where clause? Because they know that both of them filters. But when do you use which one? When do you use having? When do you use where? So where is, remember when we were using where, we don't do anything, right? So this is where, select everything from students, where this is this, straight on. But then you are doing aggregate function, and most importantly, you want to filter by that aggregate. That's another deep. For instance, I can say where department is mathematics. Mathematics. Right? And it's still throwing up an error, meaning the arrangement should be wrong. First of all, close this. So you remove this where clause from here, and maybe you try to put it here, and it's gone, right? So when you run this, it's going to run. Now it's telling you that first of all, what it does for you is that first of all, it selects department. It actually calculates the average score of those people, but it is interested in the mathematics department. Now, if I say having average score greater than 75, these two things are different. I can still come here and say where, okay, let me just leave it that way. So now you can't use where in this case because you are referring to the aggregated function. What you did here, average is an aggregate function, number one, but you want to use it to filter your data set. If you use where, it's going to drop an error for you because you are meant to use having with aggregate function. So let's try it. Let's say cut this, put it here, we run. So it's throwing up an error for us. It says the error code says invalid use of group function, right? So that's the essence. You did an aggregate function. You want to filter by that same aggregate function, and you're using where. It's going to drop an error for you. So the right syntax to use is your having. So you come back here. Having comes after your group by. So you change it to having average score as 75. It's going to be hard in the beginning, but I'm very sure that with repeated practice, it's going to stick. I'm trying so hard to actually simplify all of this. I hope I'm not getting you more confused. Having and where. You use where when there is no aggregate function, or you want to filter by just an ordinary column that you do not do any aggregation on, right? But you use having when you're interested in filtering by that aggregation that you actually did. So I think that will be the end of the teaching so that we can answer more questions. So just give me a minute to get these questions. Already. Um, okay, so I'm expecting this question practice section to be interactive. So when I ask this question, I'm expecting you to have an idea, even if you don't get it. But at times, don't keep quiet, please. At least let me see that. Repeat one or two. What's different between is and equal to? So you don't actually use is. You can use in when you are referring to a lot of things, like let's say select department and select students. That's the student's name, first name, and from where? From the student table, right? And you're interested in a condition where, what is it called? Where department of these students in. So now inside this in, you can start listing out the departments you want them to be. Maybe physics, computer science, computer science, right? So as far as you're referring to one more than one thing, you can now use in. So you can decide to be listing all of them. So now let's run. So it's unknown column department. So it's actually department. I keep forgetting. So these are the students. If you want to know if it is correct, please also select the department to know if your where clause is actually correct. So these are the students, only students that are physics in department. So there is, I'm trying to make a point that there is no is. So it's equal to. If it is not equal to, if it is either it is equal to, or it is not equal to, or it is in, or it is in between, like between keyword, like those logical operations that we covered are what we have. Any other question? How does over and partition work. Okay, that's for the next class. That's window function. I just introduced it to tell you the underlying ranking. So when we get into window functions, we treat it properly. Right? That should be my next week. Any other question? Any other question before the practice session? Any other question? Okay, so now I want to still like elaborate more on the is. So there's also something like is null. That's where you use is when you're talking about columns that are null. Is null, is true, is false. Those are the like null is actually a result keyword on its own. True is a logical function, a binary logical function, the same thing with false. So these are the three instances you can use is. If I'm interested in filtering something and I said this is equal to physics, this is a very wrong syntax. Like you cannot run. It's already telling you that it's wrong, right? So instead of is, the right thing to use here is equal to. Now I can use is null and it's going to be correct because this is the only place it should actually be correct, right? Where department is null. So we're not going to have any column because all our table have departments. Like every student that we created for this particular table, when we're starting the value from the beginning, all of them have department. There is no person we did not assign a department. If there was a student that we actually did not assign a department, let's do it. Let's drop the table and let's drop table, dropped it. Let's recreate it. Now, in the insertion, let's delete one student's department, right? Maybe this person. Now, this person does not, it might not run. This person does not have a department, so we'll go ahead and run it. So, it's not running because the conditions are not complete. It must have a department because you already indicated it here. So, you use is when you're talking about is null, is true, is false. Any other thing that you have for when this is true, use equal to. So I think that's for is. Use it with null and the boolean value is true and false. So these questions, they are not hard and they are what you just done. I think I've even answered some of them indirectly. So just let's go. So this is practice questions. The first one. First one says, find all students in computer science who are older than 22 years. Students in computer science who are older. So as you can start writing your answers or mute yourself and tell us how to go about it, or you can drop it in the group on the chat. Students in computer science who are older than 22 years. Excuse me. I'm expecting answers. Who is ready to go? Is it hard? You're interested in two columns here. The students, their department, and then I'm giving a clue. There should be a filtering clause that should select only those who are two things. Those who are in departments, computer science, and their age is greater than 22. So I think we've answered something like that. Who can go first?
Should I go first?
Okay. Who is speaking?
I
What's
want
your
to.
name, please?
Okay. Is it me?
Chidozie.
She does it. Okay,
Yeah.
yeah. Okay, so we
Okay.
should start with select first name
Mhm.
from select first name from students
Okay.
where no, hold on, sorry. Select first name, comma, age.
Okay.
Okay,
Bring that
from
again.
students where age
Mhm.
greater than 22. Where age greater than 22.
Should I run?
No, don't run yet. Students in department. Okay, okay. In computer science. I'm already confused. Select first name. Sorry. Select first name where age greater than 22. Then, comma, department. First to computer science. I don't know if this is correct though. There's already an error. Okay. There should be a comma after students.
No, that's shouldn't. Yeah, complicated things more. So it's just one thing that is happening here now. Who can help us?
There is why is it showing error?
There's one thing that is happening. Okay.
Select first name, comma, age.
Then I already corrected you.
Let me check the group.
Yeah.
Okay, select
So
students
what's
are with.
happening here? It's just an and, not a comma.
Okay, okay. Thank you.
So I decided to run it. So there is no student who's actually greater than 22. So let's bring down the age. Is there? There should be. Let me bring the age down first and see. Or okay, what is happening here is that there might be students whose age is greater than 22, but those students are not in computer science. Remember, so the and statement actually considered that both statements are true, right? So what we're having nothing here displayed because there is no student. Maybe those students are computer science, but their age is not greater than 20. And what was 22? So let's run again. There's still not somebody in computer science whose age is greater than 22. Let me give it 12. Now this is wrong. Where age is greater than 12 and department is computer science. So we run. Okay. I will exchange these two. I don't think it should affect. After this, I'll check the names that we used. So this is not normal. I'll check the names. First of all, select everything. Select everything from the table students, right? So we run this. Oh, I get. Remember that we dropped this table. We recreated it, but we did not reinsert. So that's what is happening. So currently this table is empty. So that's what is happening. So that's my bad. We dropped the table. Yeah, we dropped the table. We recreated it, but we didn't end up reinserting the values. We didn't end up running that insert value. Where is it? We didn't run this part, so let's run it. So the values are inserted now. So let's go back. First of all, let's select everything. So now this is everything. So this should run now. This should run now. So when we now run this, we are still not having an output because it's actually maybe there are no students in computer science whose age are greater than 20. So let's use 12. So now you can see that both of their ages are 20 on the dots. So if this was going to work, what would have done is greater than or equal to 20, right? If this was actually going to work. So thank you very much, Chidozie and Nena, for this question. The second one, we want to get the top 3 students with the highest scores. So start thinking about it. Get top 3 students with the highest scores. Anyone? Get top 3 students. So from this thing, which columns are we interested in? We're interested in students, we're interested in high scores, and a lot of small touches that we should do. So who's going? Anyone? Hey, this one that hard. Wait, let me be calling it one by one. She my gem. Oh yeah, it's your turn. Try. Start with select first. Then somebody will help you to complete it. Okay, somebody just dropped something. I'll just copy it and run, and then okay. So this is select student. Have sent this. Select student, the name. So this is wrong. That's why it's flagging it. What we have is first name. Name is a reserved keyword. Department and score. Do we really need all these things? Do we? Students, other score by descending, and top 3. So it's telling us unknown column student ID. We don't have student ID, do we? No, we don't. So your query is wrong. So this is it though. So it's just run now. So what we're interested in is actually students with higher scores. We're not interested in their department. So always know when to put columns that are necessary. So we're not interested in just the first name and their scores. We're not interested in which department we are coming from. So let's just deal with what we were asked for, right? So this is actually correct. Thank you very much. Thank you very much. Yeah. So Hafsa, thank you for that. That's a good attempt. Next question. Next question. Show how many students are in each department. Show how many students are in each department. I think we've done this one. Yeah, we've done it. Show how many students are in each department. This definitely requires a group by, just a tip, because we are trying to group by departments. So let's go. go. Let's go. Anyone? Anyone?
Let me try.
Is someone speaking, please?
All right, and select
Okay.
and students. No, select name.
Okay, that should be first name. I'll help you.
Yes, select first name. Sorry. Then count
Okay, nice.
as students. That is
What are we
as
counting?
student. We are
What are
counting
we
as
counting?
students.
No, as
Sorry.
students, she's meant to be yes.
Okay. Select. Let's do select first name or select department first name. Then count.
Select department. First name. Okay.
And count as students.
Okay. I'm writing what you said though.
No, the student should be as students underscore count, then from students. Then we group by department.
Okay, so let's do this. And the error message is saying that there is unknown column count in the field list. So the way you said this thing, it's saying this count as a column, and there is no column like that. So that was what I was saying. What are we counting? Because this is an aggregate function. A function, there should be some, always has this two asterisks, and then what you are referring to will be inside it. So what are you counting in this case?
Okay, let's count all. So let's put star asterisk here.
So still saying group by clause contains non-aggregated column. So we don't
The
really.
group by department, is it not supposed to have the was
So the row
I'm forgetting
was that first name. Yeah, there was the first name. Right. Should
Okay.
group by if you list 5 columns here, group by is expecting you to make use of those 5 columns that you listed. And the question already says students in each department. We're interested in the students and their accounts. So this is what we are having. Let me see the other responses in the group chat. My video is paused. Is it true? So Chima Jem said select department, count as students, group as departments. I guess you already saw the correct one, so your answer is wrong. Then said select department, count everything as total students. Group, that's very correct. Ages also got it, yeah. So Chima Jem should know where your error is now. So the question again is list students whose name contain SON. List students. So you can start dropping your answers. List students whose names contains. I want to change this thing so it will actually carry actual. I think there are students that their name contains, say R. Yeah, students whose name contain R. So once that name, you want to see it. Oh yeah, who is leading? There are people that have not spoken in this our call. It's like I'll be calling them one by one. 001. Oh yeah, it's your turn to speak. Jamila. Sarah, how far? Are you with us? 001, no, don't tell us. Don't give us that emoji. We need the answer. Try.
Yeah. So, select. 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 Student name.
Do you have a column like student
That's
name?
first name. Sorry. Select first name. Student tools contains arrow. And from student. Okay. You need don't please need comma from student. Is it group by? Sorry. Like where uh, I don't know, but that arrow is supposed to be in that percentage something, but I don't where.
Okay. Okay, let me see. It's already helping you out. The wildcat. Yeah. So she does already dropped it. So I'll just copy what she gave us. And she got it wrong. I think the person that got it right is Adakuli. Yeah. Her first name. Where first name. So this person actually omitted the like. Right? So we run. So why are we having this? So this is how it should be. Right? So we run. And these are the only two people whose names contain R. Thank you very much for your
Is that single
contribution.
quotation?
Yes? Yes,
Is that
yes.
single? Okay. You don't
Yes.
use double here.
You can try to use so far you're consistent with it. Still, the main thing is let it recognize it as a text. Still the same thing. Right? They serve the same purpose. Okay. So the next question. Select oh god. Count how many students scored above 80 in physics. Count how many students scored above 80 physics. Okay, so who's going for that? So that we can touch on the what is it called? Can touch on the advanced filtering before we close. I'm waiting for responses in the group. Has anyone dropped the answer? Let's check. Not yet. What's happening for this question? Count how many students scored above 80. Is what ah. Okay, I'll take Inena's own. Let's run first. Okay, so ages, I think you got it. Select. So both of you got it. Yeah, both of you got the correct answer. Same with Adakule. Thank you guys. So there's actually nobody in physics who scored above 80. So the count is 0. But the query is correct. Thank you guys. So all right. So before we round up, I want to introduce the concept of join. Lena, please, can you open the attendance group? Okay, so I want to introduce the concept of join so that when we come in the next class, we know we will touch everything that because we don't anymore. So for joins, right? Joins are like I said before, how the assessment, that's true. Today is, I said the deadline is going to be Saturday. So the group should still be open for people so that they can submit it by Saturday. Deadline is Saturday. We'll do the collection on Sunday, both of us. So I'll chat. So those that not submitted the assessments, we still have from now to Saturday to submit it. Okay. Like I said before, joins help you to connect two tables together so you can see related information in one place, right? So this is because in you normally store tables differently. For instance, if I'm interested, like I will use two scenarios to explain. Let me use a school system, number one. So for school system, I have computer science, right? And I have students in 100 level, I have students in 200 level, I have students in 300 level. Of course, these are already tables on their own, but all of them are inside the database of computer science students, right? So now I can use join to actually merge the 4 tables together. And if I'm doing that, the rule of thumb is that all of those 4 tables will have something in common that they should bank on, right? Maybe the ID, the IDs in their different tables correspond. What I mean, we are talking about, I don't want to use your range number because range numbers are always different. But the point is that most of them usually have the same ID, just like you doing a lookup reference in Excel. Of course, the dimensions of the table have to be equal, right? For both of them to work. Okay, let me use a different one. Let me use a sales or transaction record. There's the other table. there is the product table. This other table has what is it called? This other table, and there is the menu table too. There is the menu table. Menu, right? So menu is now talking about the product itself. If I'm not mistaken, I'm trying to put one or two together. So now this other table has, say, people who ordered it and the time they ordered it. That means in this case I'm talking about my customer ID and the order dates, right? This is what this one has. Then the menu has the product ID and the product name, because it's actually talking about the menu that this customer ordered. And I don't think this is the right name for this person. So the last table should be about order menu. Let me talk about price. Yeah, something that should contain the price. So I'll do transaction table. So this transaction table now, you have the customer ID, because I need to know the customer that made that transaction. I need to know the product this person bought, so it will have the product ID. And probably I don't want to know the price, like the amount the person sent. The amount. Good. Yeah. So these three tables now, let's work with them to explain what we mean by joins. Just briefly. I'm not writing any queries yet, just the explanation. So now, if you look at this table, there's a relationship between all of them, right? I can from menu connect transaction, because product ID here and product ID here are the same thing. So there's a relationship between both of them. If you strictly want to connect menu and other table, you cannot do it. Why? Because there is no common column between both of them. Product ID, product name, customer ID, order date. So there is no like a direct relationship. You have to go through transaction. So if I want to connect these three tables, what I can do is I'll connect menu ID here to I'll connect product ID here to this product ID, and then I'll connect customer ID here to this customer ID. And in doing this thing, these three tables now have a relationship. And how do you connect this connection we are talking about? Is join. So you can do inner join, left join, right join, self join, cross join, like a lot of joins. We're not going to go into details because I just want to introduce it, right? So this, like, even if you're working with 10 tables, so far these 10 tables have like common attributes, that's columns that have relationship with them. You can join them. That's one way. Another way is actually creating these things from the initial. When we're creating tables here, this is the table we created. If you actually wanted to create another table here, and we want a connection to be between this table, we can decide to add student ID here, right? And instead of altering this whole table, let me copy it and go back and start like create another table for what you want to do. Instead of altering everything, so I can create student ID. It's going to be an integer. So now this is it. Student name, first name, okay, yeah. So now Remember, this is the primary key in this key now. The primary, we already talked about primary key. Primary keys are unique identifiers. So most times, just like here, things that connect tables, that join tables are usually their primary key. So now, in this particular table, this is the primary key here for this menu table. For the other table, this is the primary key here, right? And when you come to transaction table, this becomes a what? You can tell me. These two things here, appearing here, are what? Anyone, any idea? It's from the first class. When you have a primary key appearing in another table, what do you call it? Have a primary key appearing in another table, what do you call it? Any idea? Any idea? What about people that don't have system? Wow, I didn't see that message. Okay, about the assessment. I'll get back to you on that question. I'll get back to you on the question. Remind me. So I'm asking this question. When a primary key, which is a unique identifier for each table, appears in another table, what do you call it? It's called a foreign key, right? That's correct. So now, it's a foreign key. These two things are foreign keys in this table. Why? Because in their different tables, they are primary key. But seeing them in another table, they become a foreign key. So I'm trying to say that if I'm to create these tables and I want to add a foreign key, the syntax is, you can actually write it foreign key. Then the name of the foreign key, let me just give an arbitrary name, just product ID. You don't need to understand these joins now because we have a dedicated session for it. But why I'm introducing it is that when we come, these long talks I just did, I will not do it. I'll just go straight into the types of joins and start writing their syntax and their queries, right? So that's what I'm introducing in this class so that you have an idea. And on your own, you can go and read up on joins. Please read up on joins because it can get complicated. And come with your questions in the class so that those complications will not rise. Please. So this product ID, want it to reference another table. Maybe the table name is product table. And of course, it must carry this thing. So this is like how you indicate that this is a foreign key. So this is references product ID. Then you terminate it correctly. Now I'm getting this foreign key. This is foreign key. So I have to still reference it. We are still having this. So and close this. Now if you run this, it's going to drop an error because we don't have this table, the product table. So I think I'm running. I can feel like I'm running. So and I can feel that I'm causing more confusion. So let me stop at this point and reiterate what I've said before. Joins help you to connect tables, two or more tables, right? And for you to do that, they must have a relationship. Yes, that's the right word. They must have a relationship. Now, what kind of relationship should they have? They must have columns that are the same thing that you can make reference to. That's the meaning of these references. In this case, these two tables have a relationship because the product ID here must be equal to the product ID here, so that they can say menu. We can ask if you are creating this particular table, we can say that it is referencing the menu table, and inside the menu table it is referencing this particular column. So that's what like join does for you. So there are so many types of join. There's inner join, there's left join, there's right join. These are the three most commonly used joins, right? There's also cross join, which you hardly make use of. There's self join, although it's not compatible with MySQL. You can find that one in PostgreSQL or MongoDB, all those other databases. There is a lot of them which we are going into. So after joins, which I hope we'll cover, we'll do subquery, and then we talk on window functions. These three outstanding topics are what we need to cover. So on your own, you can just do small research. Research on joins, research on what is subquery. Subquery is like nested queries, so that one's it's not really a big deal. Research on window functions so that you understand what is row number, understand what is dense rank itself. So yeah, that will be all for today's class. I hope that you picked a lot from today's class, and that on your own you can write queries. Like I said before, practice makes perfect. You're not going to learn this thing by listening to me talk, right? You learn it by doing it on your own. You learn it by doing it on your own. So thank you for coming to today's session. I don't know if the recorded session is still needed. I'll still provide it. Okay. Please take your attendance and please work on your assessments. Deadline is on Saturday, right? Good night, everyone. Thank you for coming. Please come on time next time. We came a bit late today. All right then. Yeah, I'll make it available, recorded sessions.